Good morning, students. In the last classes, we have done the different units, the multiples of the units, and some of the units that we use in day-to-day life, some of the commonly used units. In this session, we will be starting with the topic dimensional analysis. Now, what is dimensional analysis? It is a technique in which the units of various physical quantities which are involved in any type of calculations are analyzed so that the values are put up in a formula in proper units. Let us just take an example. If I give you a simple question, 5 kilometer plus 5 meter equal to, what we will do? Will we add them and write the answer as 10 meter or 10 kilometer? Is it correct? No. What you will do? You will analyze. Both the quantities should be in the same unit. We know that 1 kilometer is equal to 1000 meter. So it will be 5000 meter plus 5 meter, and the answer will be 5005 meter. That is the correct answer. So we have analyzed the quantities that we are using, their units have to be proper before carrying out any mathematical operation. Now in dimensional analysis, we will use a particular method which is called as the unit factor method. That will help us to convert one unit into other. Now, unit factor method, we will be starting with a very simple example, and then every step we will go to the more complex examples. Let us start with an example in which I am using the unit factor method. Suppose I have a simple question. I have to convert 9 kilometer to meter. Now, I know that all of you can directly convert it into meter. But what we are using here is the unit factor method. To use this method, first of all, whatever units are given to us in the question, we must know the relationship between those units. So what is the relationship? We know that 1 kilometer is equal to 10 to the power 3 meter. This is the relationship between the two. Now, if I bring this side, so it will be 1 kilometer upon 10 to the power 3 meter is equal to 1. That means this is equal to 1, so we call it a unit factor. Unit factor means whose answer is 1. So when I divide 1 kilometer by 10 to the power 3 meter, I get 1. So this is one of the unit factors. Another unit factor, I can do one thing. If I take 1 kilometer this side, so I can write 1 is equal to 10 to the power 3 meter upon 1 kilometer. This is another unit factor, and both of them are equal to 1, that is unity. So I can make them equal, and we can write 1 kilometer upon 10 to the power 3 meter is equal to 10 to the power 3 meter upon 1 kilometer. Now, using these unit factors, I will convert 9 kilometer to meter. Now what I have to do, I have to write 9 kilometer, and I have to multiply it with one of the unit factors, either first or second, in such a way that the unit that we don't need gets cancelled out, and at the end only that unit is left which we require. Which unit we require? Meter. I have to change kilometer into meter. So I don't want kilometer, no longer want kilometer. I want only meter. So what we will do? 9 kilometer multiplied by this second, 10 to the power 3 meter upon 1 kilometer. Kilometer and kilometer gets cancelled. So our answer will be 9 into 10 to the power 3 meter. This is how we use the unit factor method. Let us take one more example. Second example, 5 nanosecond to second. Now first of all, we must know the relationship between nanosecond and second. So let us see what is the relationship between the two. In the table, we have done the multiples and the decimal fractions of the SI units. To go through that table, you have to learn that table in order to know the relationship. The relationship is 1 nanosecond is equal to 10 to the power minus 9 second. Actually, 1 nano is equal to 10 to the power minus 9. So I can say 1 nanosecond is equal to 10 to the power minus 9 second. I can make the unit factors. How I can make the unit factors? I can take this side. And another one, 10 to the power minus 9 second upon 1 nanosecond. Same way as we have made it here. So 1 nanosecond upon 10 to the power minus 9 second equal to 10 to the power minus 9 second upon 1 nanosecond. These are the unit factors. Now we consider 5 nanosecond. I have to convert into second. So either I have to multiply by first or with second in such a way that nanosecond should get cancelled. So I will multiply by first or second. Because in second, the nanosecond is in denominator. So 5 nanosecond multiplied by 10 to the power minus 9 second upon 1 nanosecond. Nanosecond gets cancelled. So the answer is 5 into 10 to the power minus 9 second. So this is how we use these unit factors. And how we make the unit factors? We must know the relationship between the two units. And once I put this in the denominator, next time I put this in the denominator. So these are the two examples. We proceed with the other examples. Third, I am taking example 5 liter 2 cubic meter. Same principle applies. I must know the relationship between liter and cubic meter. What is the relationship between them? 1 cubic meter is equal to 10 to the power 3 liter. Let us make the unit factors. 1 cubic meter upon 10 to the power 3 liter is equal to 10 to the power 3 liter upon 1 cubic meter. These are the unit factors. Now, I have to convert 5 liter into meter cube. 5 liter multiplied by, I have to cancel liter. So I have to multiply by first or second. Obviously first, because liter is in the denominator. So it is 1 cubic meter upon 10 to the power 3 liter. Liter and liter get cancelled. So it becomes 5 into, when 10 to the power 3 goes up, it becomes 10 to the power minus 3 cubic meter. Clear with this method of unit factor? Slightly a higher step we will go, a different unit we will convert. Let's see. Suppose I am driving a car with a speed of 60 km per hour. Now I want to change the unit to meter per second. I want to know per second how many meter my car covers. So in this, can you see there are two units involved? Kilometer, meter, hour and second. Let us see. What is the relationship first between kilometer and meter? 1 kilometer is equal to 10 to the power 3 meter. And another relationship between hour and second. 1 hour is equal to 3600 seconds. You can make the unit factors for both of them. 1 kilometer upon 10 to the power 3 meter is equal to 10 to the power 3 meter upon 1 kilometer. 1 hour upon 3600 second is equal to 3600 second upon 1 hour. Now, I will be converting this unit into that. Let us start. 60 kilometer upon hour. I have to multiply in such a way that first I cancel kilometer. So I will multiply by first or second? Second. So it will be 10 to the power 3 meter upon 1 kilometer. Kilometer gets cancelled. So I have converted kilometer into meter. Now I have to convert hour into second. So it will be, I have to cancel hour. Hour is in the denominator. So what it will be? 1 hour upon 3600 seconds. Hour and hour cancels. Solving the remaining 60 into 10 to the power 3, that is 1000 upon 3600 meter, and when I bring second above, it is second minus 2. Then I solve it, I get the answer 16.67 meter per second. So these are few of the examples of dimensional analysis in which we use unit factor method. In the next session, we will be doing with more examples of this topic. Thank you.